Okay, let's dive right in. We're going to talk about something you probably do every day, refactoring, and see how it can be like a secret blueprint for your entire engineering career. It's pretty cool. All right, so let's get right to it. From code to career. We all know good engineers, right? But what's the unifying principle? What's that secret sauce that makes someone a great engineer? It's a question that, honestly, gets to the very heart of what it means to grow and have a massive impact in this field. Yeah, what is the real difference between a good coder and a great engineer? Is it just about writing fancier algorithms or, more complex code? Or is there something else going on, a different way of thinking that unlocks that whole next level of contribution? And here's the split. It's all about scope. A good coder, they're laser focused. They write clean, efficient, correct code for the task at hand. And that's awesome. We need that. But a great engineer, they zoom out. They're not just building one little part. They're improving the entire system they work in. We're talking the codebase, the team processes, even the team itself. And the bridge between these two roles, the mindset that lets you make that leap, it all comes down to one powerful concept, something every single one of us already knows: refactoring. Okay, so let's get on the same page. Here's the classic definition from the legend Martin Fowler. Refactoring is a disciplined technique for restructuring existing computer code, altering its internal structure without changing its external behavior. The key phrase there is without changing its external behavior. You're not breaking anything. You're just making the code easier to understand, cheaper to change later on. It's not about adding shiny new features. It's about making it way faster and safer to add all the future features. And that right there, that's the big question for us today. What happens if we take this idea, this principle of continuous, safe improvement, and just apply it everywhere, beyond the code, to our teams, our organizations, and even our own careers? All right, section 2, spotting the smells, from messy code to organizational friction. So how do you even know when to refactor? Well, it all starts with learning to spot the smells. So what the heck is a code smell? It's not a bug, okay? The code works just fine. But something just feels a little off. It's a hint, right? A little warning sign that the design could be better and that it might cause you some real headaches down the line. And this is where it gets really cool. Check this out. On the left, a classic code smell, duplicated code. You got two functions doing basically the same thing. It's confusing, it's a nightmare to maintain. We've all been there. Now look at the right. Tanya Riley calls this an org smell. Two different teams building almost the same solution. It's the exact same problem. It wastes a ton of effort and creates massive integration problems later. It's a sign of a deeper issue, right? Like maybe a lack of communication or a fuzzy technical vision. And this quote from Kent Beck and Martin Fowler, actually quoting Grandma Beck, just says it all, doesn't it? If it stinks, change it. The refactor mindset is not passive. It's this active, constant state of vigilance. Whether you see a chunk of confusing code or a totally broken team process, the impulse is exactly the same. Don't just complain about it or work around it. Fix it. Okay, so you've spotted a smell. Now what? How do you actually fix it without, setting the whole building on fire? The answer is all about taking small, disciplined, methodical steps. Fowler's process for this is just beautiful in its simplicity and safety. First, you need a safety net, a solid suite of tests. Step 2, you make one tiny little change. I'm talking rename a variable, extract a method, something small. Step 3, you run the tests. Did anything break? No? Green lights? Awesome. Step 4, commit and do it again. Repeat. This whole process just removes the fear from the equation and lets you move fast without creating a mess. But let's be real for a second. That super clean step-by-step process, it rarely looks like that in the real world, especially for a senior engineer. I mean, look at this chart from Tanya Riley's work. This is reality. Your week is a mess. It's fragmented. You're pulled from your main project to fight fires, sit in endless meetings, and juggle a dozen side quests. And here's the most important takeaway from this. Even in all that chaos, the core principle is exactly the same. You're not going to fix your organization's technical strategy in one giant leap. It just doesn't work that way. It's a series of small, deliberate changes. It's writing that one clarifying document. It's facilitating that one meeting to get two teams on the same page. It's fixing that one clunky API. Each step is small, it's safe, and it moves the entire system just a little bit closer to a better state. This brings us to the big picture. the ultimate goal of all this refactoring, both in our code and in our careers. It's not just about tidying up the mess from the past, it's about building a better future. And man, this quote from Martin Fowler is just so spot on. Often, the fastest way to add a new feature is to change the code to make it easy to add. Think about that. You don't just cram a new feature on top of a messy system, no. You first refactor the system so that adding the feature becomes almost trivial. It's what you'd call preparatory refactoring. You invest a little bit of time now to save a massive amount of time later. Okay, now let's scale that idea way up. At the organizational level, this is exactly what shaping a technical vision is all about. You're not just making it easy to add the next feature. You are refactoring the organization's architecture, its platforms, its processes, so that dozens of teams can build features easily for years to come. That's the game. And these two images just illustrate that shift in perspective perfectly. On the left, you're organizing code, right? You're moving a function to a better spot inside a class. It's important, but it's very local. On the right, that's the staff engineer's world. You're placing your work within the vast, complex map of the entire organization. Your job is to refactor the connections between those distant stars. So, finally, let's bring this all home. How do we apply this mindset to ourselves? How do we literally refactor our own role to have the biggest possible impact? As Tanya Raley points out, your most precious, most finite resource isn't your coding ability, it's your time. You simply can't fix every single code smell or every organizational smell. So, the real essence of a senior role is being deliberate. It's choosing which problems are the most important ones to solve, which refactorings will give the entire system the most leverage. And this slide is a perfect example of that strategic trade-off. You might be faced with a boring project. Maybe it doesn't teach you the latest, flashiest tech, but look at the impact. It could dramatically boost your team's social capital, unblock a bunch of other teams. It's a strategic refactoring of organizational debt. And sometimes that is way, way more valuable than just optimizing for your own personal skill growth. So, to wrap it all up, here's the game plan. You want to refactor your role? Start by actively hunting for the friction points, the smells, in your team and your org. Then tackle them with small, incremental, safe changes. Always ask yourself if your work is aligning with that big picture vision. And finally, learn to love the boring work that unblocks everybody else and improves the whole system. That right there is the heart of senior level impact. It's a really powerful way to think about your own growth, isn't it? It shifts your focus from just doing the tasks you're assigned to actively improving the entire system you're a part of. So the question for you is, your code, your team, your career, what will you refactor next?